with the late start. I just had to get a couple things in order before we began. And just gotta update the website, make sure everything's up to date. Okie dokes. Perfect. Am I gonna go for a walk? I don't know. It's pretty nice out, isn't it? Yeah, I might go for a walk. Why are you? Maybe. Oh, nice. Nice. Yeah, as far as I understand, I think that going for walks and stuff is perfectly fine as long as you're keeping your distance between people. Just keep a safe distance of 6 feet or so, and I think you're okay. I think that's what the government is saying. So yeah. Yeah. Yeah, I hope it wouldn't come to that. But yeah, I think it's all good. Yeah, I heard that a few people have been given tickets. Yeah. Okay, so I've got it. I think everything's all in order. I think I'm on YouTube. The website's up. Okay, so I wanted to just do a couple examples, and then I want you guys to try some examples too. So we're going to talk a little bit about non-permissible values, NPVs today. Non-permissible values. So remember that the NPVs, these are values that lead us. These are values that lead us to divide by 0. Divide by 0. And dividing by 0 is bad. This is something that is a big theme in math. I mean, probably the first time you heard that you're not allowed to divide by 0 was maybe like grade 3 or grade 4 or something. You know, when you first start learning about division, maybe somebody tries to do division by 0 and then it's like, what the heck, this doesn't work. And then it never goes away. You keep talking about it and you keep talking about it. And then even when you get into, bigger topics like calculus or even like abstract algebra and linear algebra and analysis, this topic just never goes away. So dividing by 0 is a major topic in math, and it's one of the few topics that you start talking about at a very early time, like grade 3 or so, and then you keep talking about it like, mathematicians in their 70s are still talking about how you can't divide by 0 and all the interesting things that are related to that fact. So the non-permissible values, these are kind of like, x does not have, or it could be any variable really, but let's just say our variable is x. So the x does not have permission, I can't spell today, mission accomplished, does not have permission to equal these values. Okay, that's what the non-permissible values are all about. Okay, like x does not have permission. That's what the permissible thing means. Okay, so let's start off by just a few quick examples. So let's state the NPVs of this rational expression. So this is going to be 1 over 2x minus 3. Okay, so the question here, the thing that should be going on in our brain, like the thing that, like, if we're looking for NPVs, what we want to think about is, when does this denominator equal 0? Okay, so like, which values of x give us a denominator of 0? Well, it's really not that hard to figure that out. So what we're going to do is we're going to take our denominator and we'll set it equal to 0. So we'll say, okay, so what I want to know is when does this equal 0? And if I can figure out when that's equal to 0, that's what I can prevent. So if 2x minus 3 is equal to 0, that gives us a problem, right? this gives us a problem. Oops, problem with an E, problem. Okay, so if that gives us a problem, let's figure out whatever that problem is. Like what value of x gives us that problem. So we'll have 2x equals 3 and x equals 3 halves, or 3 over 2. That's it. So our NPVs, NPV are non-permissible values, are x cannot be equal to 3 over 2. Okay, and that's how we express it. Some people, like some math teachers, have different ways that they would like you to write this. I tend to not really care how you write it, as long as you're clear about the fact that these are NPVs. I know that I don't know who your math teacher is going to be next year, so sometimes it's a good idea just to know the different sort of the different conventions, because some people have different expectations. So another way you could write this is your NPVs are, you can write it as a set. So you may have more than one NPV, so you might have more elements in this set. So that's why we use this set notation. Some people say that your NPVs you could write is x equals 3 over 2, because when x equals 3 over 2, then you divide by 0. So all of these are they mean the same thing, really. You're stating what values x cannot be equal to. And you're basically just saying x can be anything except these values. And there's several ways of saying that. It's kind of one of those things that it's confusing because you're talking about a negative thing. Like you're talking about values that x is not equal to. So do you say x is not equal to 3 over 2? Or do you say like these are all the values that x can't be equal to? Or do you say the values that x cannot be equal to are these ones? Like when x equals 3 over 2, it's bad, right? So as long as you're clear about what your NPVs are, I don't really care how you express it. It all really means the same thing. But just know that different people have different expectations, and some people may have very specific expectations about how you express your non-permissible values. So let's try another one. Let's do. Okay, I'm gonna get you guys to try this one. I want you to try this one. So this one is for you. I want you to try this. So I'll write you try. You try. Okay? So I want you to state all NPVs for this guy. So 1 over x squared minus 5x plus 6. Okay? So I'll give you, let's see, how about 4 minutes? I'll do 4 minutes for this one. I think that's more than enough time, 4 minutes. So yeah, I'll give you 4 minutes starting now, and give that a shot, and we'll see how this fares. Oops, how about like this? There we go. Okay, I'll come back in 4 minutes. I'm just gonna get some water and clean my desk for a second, and when I come back, we'll go over this solution. Okay, looks like we're just about at time. Oh, and Goose decided to take a little nap on my iPad. Isn't that nice of you, Goose? Yeah, what a sweetheart. Okay, so the idea of this one here, if you didn't already, let me get rid of this. If you didn't already get it, is you got to factor it, right? So just like before when we were looking at, oh, what did I do here? Oops. Just like before when we were looking at, like when we were looking at quadratics and we wanted to know the roots of a quadratic, well, we were looking to see when a quadratic is equal to 0, okay? So, oh, she's just all splayed out here. Oh, now you can see my calendar. Oh, I wish you could see this. Here. We'll do this. There she is. Little sweet little kit. Yeah. I'll just film this while I talk. So just like before, we wanted to find out when a quadratic is equal to 0. What we would do is we would factor it and then set each of those factors equal to 0 and then solve for that. So let's solve that, and then as a little reward for all of our hard work, I'll send you a cute little video of what Goose is doing right now, because she's actually being completely adorable and she's just off screen. You can't see her, but she's being unbelievably cute. And this is basically what I deal with all day. She kind of, sometimes you sort of see her on screen a little bit, and then but really she's like right front and center. So, hi sweetie pie, it's time for you to move. I know, how could I do such a thing? How could I be so mean to such a cute little kitten just trying to take a nap? Yeah, I know. It's a hard life to be a cat. Okay, let's move you over here. Bring this over here like this. That's better. And where'd my pencil go? I think she's lying on top of it. Goosey, what'd you do with my pencil? Okay. There it is. Yeah, she's lying right on top of it. Okay. Okay, so what we're going to do is we're going to factor, the numerator. And now Goose is going to try to eat my pencil while I play. Yeah, what a fun game. This is great. Okay, so let's factor the denominator. So the numerator stays the same. The denominator, however, I'm going to say that, okay, I'm saying that we've got to have a -5 and a -6, or sorry, -5 and +6. So I'm thinking 2 and 3. So this is equal to x minus, Goose, x minus 2, Goosey, x minus 2 times x minus 3, right? Because -2 times -3 is +6, but their sum is -5. So this is 1 over x minus, Goose, oh, my goodness, 1 over x minus 2 times x minus 3. And that's, I factored the denominator there. So we have a problem. So our problem is when the denominator is equal to 0. And the denominator is x minus 2 times x minus 3. When that's equal to 0. And we're familiar with that, right? So that happens when either that's equal to 0 or that's equal to 0. Right? Either of those things being equal to 0 would lead us to have the entire thing equal to 0. So let's go ahead and solve for that. So if x minus 2 is equal to 0, that means that x equals 2, right? And if x minus 3 is equal to 0, that's x equals 3. So the non-permissible values, the NPVs, are the following. X cannot be equal to 2, and x cannot be equal to 3. Another way of writing it, if we want to use set notation, is that the NPVs are the following. We have the set that has 2 and 3 in it. So that's the set of all non-permissible values. So either of those will be fine. Doesn't really matter to me how you express your NPVs, just as long as you're clear about it. Okay, and as a reward, I told you we'd watch a little video of little Goosey Poo. So let's do a little airdrop, and then you can see Goose. There she is. Yeah, so there she is. You can see she's lying right on top of my iPad, right where I wanted to do some work. But what can you do? Yeah. Yeah, she's pretty sweet, eh? And she's pretty much doing the same thing. I just kind of kicked her off the top of my iPad. She just does this all day. She's very, like, attention hungry. She loves attention. Yeah. Okay. Yeah, that's probably good. Let's move on to the next problem. Yeah, Goose, you're internet famous. She's been getting very internet famous over the past couple of weeks. Yeah, lots of airtime. This has been really good for her fan base. Okay, let's try this one. Okay, this one's kind of like a level 3 difficulty. Let's try this one here. Let's do this one here. No, not that one. I don't want that one. I want to try this one. Yeah, I want to do this one. Okay, so we're gonna look for. Okay, we're gonna do this. Okay, so we're gonna do two things now. We're gonna do two things. Okay, so we are going to So for the following rational expression, we're going to do two things. First thing, one, we are going to simplify. And two, the second thing we're going to do is we're going to state all non-permissible values. Non-permissible values. Oh, Goose, why you gotta be so cute? She's just basically being adorable, and it's really hard to ignore. It's so hard to ignore a cute little cat. Okay, so yeah, I'm gonna give you this rational expression, and you know what? Actually, I'm gonna do kind of like a level A, a level B, and a level C. Kind of like A is going to be sort of the straightforward difficulty. B is going to be a little bit harder, and then C will be a little more challenging. Okay, so let's try it. I've got the part A is going to be 4/3 pi r cubed divided by 4 pi r squared. Okay, it's a great question. Okay, so we're gonna look at this question right here, and so I want to simplify it. Now, what do I mean by simplifying? Well, let's take a little step back towards, maybe close to like a grade 8 type of problem to kind of look at some of the stuff that we're already good at. So if I asked you to simplify this fraction, and the fraction was, I don't know, how about 8/12? What would you do? Well, you'd say, okay, well, these have some common factors, right? There's factors that are common between 8 and 12. So common factors, in fact, what we would do is we would say the greatest common factor of 8 and 12 is, well, 1 goes into both of them, obviously. 2 goes into both of them. 3 goes into 12, but doesn't go into 8. 4 goes into 8 and 12. And I'm pretty sure that's the highest one, right? So 4 is the GCF. So the GCF of 8 and 12 is equal to 4. Okay? So that's what we're going to divide. So I know that both of these are divisible by 4. So I'm going to divide the top and bottom by 4, and I'm left with 2/3. So 8/12 is equal to 2/3. They mean the same thing. They have the same value. So in the same vein, what we're going to look for in this rational expression, we think of rational expressions as kind of being just fractions, right? I should post cats on my Instagram. Yeah, I probably should. Believe me, I have lots and lots and lots of cat photos. Many to go around. So yeah, maybe I'll start doing that. If you're on Discord, someone on YouTube just posted I should post more cat photos on Instagram. Okay, so yeah, I'm gonna look for, like, do we have any common factors? Do we have common factors among these? Yeah, we do. We got a lot of common factors. So first of all, I see a 4 here and a 4 here. Okay, that's good. I see a pi here and another pi here. And I see some r's. So we've got some r's in common as well. In fact, we've got 2 r's. We've got r squared in common. Okay? So let's think about how we could factor this out. So basically what I'm going to do is I'm going to divide both sides by, so we're going to divide both of these by that common factor. So I'm going to divide by 4 pi r squared, because both of these terms have 4 pi r squared as a factor. So I've got divided by this and then divided by 4 pi r squared. Great. So when I do that, what I'm left with is, well, I've got 1/3, the pi's disappear, and I've got r left over, because r cubed divided by r squared is just r, divided by, well, I've got 4 pi r squared divided by 4 pi r squared, which is just 1. So in other words, this is 1/3 of r, or if you really please, you could write r over 3. Okay? So there you have it. All right, let's do question B. Are there any questions about this before I move forward, though? Because this is. Oh yes. Thank you for reminding me. NPVs. Okay. So and I see your question there. I'm gonna hold up, but I'm actually gonna just write the NPVs first. So the NPVs. So these are values that give the denominator a 0. So the only variable that I have here is r, right? 4 is not a variable. Okay, I'll get to that question in a second. So on YouTube, someone asked, how do you divide 4/3 by 4 and then end up with a third? I'll show you that in a second. So, so r is the only variable because pi isn't a variable. I know it doesn't look like a number, but it is actually a number, right? It's 3.14159, blah, 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 blah. So that's not a variable. The only variable is r, and whenever r is equal to 0, this whole thing is equal to 0. So the non-permissible values are just r equal to 0. R can be anything other than 0. Okay, so this is the only non-permissible value that we have. Okay, now you might notice, hold on, we said that it's equal to r over 3, and there's no r in the denominator of r over 3, right? R is just in the numerator. Well, that's because we removed r from the denominator. We removed it from the denominator when we divided it by r squared. But when we're looking at NPVs, we're not looking at the final value. We're interested in the original question. Okay? So in the original question, are there any values that r can't be equal to? That's what we need to look at when we're looking for NPVs. Now, to address someone's question on the chat, the YouTube chat, so let's talk about this. So 4/3 divided by 4. Okay, so let's talk about how to tackle this. So I'm gonna say, okay, so 4/3. Let's take a look at what 4/3. There's several ways of approaching this, by the way. I'll do 2 different ways of approaching this. So one way to approach it is to say, okay, well, 4/3, that's like how many thirds? It's 4 thirds, right? So how many of these do we have? We have 4 of them. So this is 4 times a third, right? That's what 4/3 means. It means 4 times a third, because we have 4 thirds. And that divided by 4 is, well, let's figure that out. Well, I've got a 4 multiplying by a third, and then I'm dividing by 4 again, right? So doesn't matter, any number if I take any number except 0, any non-zero number. And if I multiply it by 4 and then divide it by 4, I get the same thing back. And as a matter of fact, that actually does work with 0 too, so never mind. Take any number that you can think of, multiply it by 4, then divide it by 4, you're going to get the same number back. So this is 1/3. So 4/3 divided by 4 is 1/3. Another way to think about it, so this is like way of thinking A. Another way to thinking with B is just to think pure fractions. So to go all out with your fractions. So I've got 4/3 divided by, so if I take something and divide it by 4, this is the same thing as multiplying by 1/4, right? If I multiply by if I divide by 4, it means exactly the same thing as multiplying by 1/4. So if I could multiply this by 1/4, now look at this. I've got a factor that's common to the numerator and the denominator, which is of course 4, and that's equal to 1/3. So that's the second way of thinking about it. Okay. Okay, so yeah, like I said before, when we're looking at non-permissible values, we only look at the original question. We only look at the original question, and yeah, and I've got to just send you a quick pic of Goose because she's being like way too cute to ignore. And I got to show you her big fangs. She's got very sharp fangs that are very deadly. Okay, check these out. Okay, I gotta share these. Okay, share that one into my iPad. There we go. Oh yeah, okay, here it is. Look at those teeth. Oh man, those could do some serious damage. And oh yeah, that's the one. We already looked at that one before. Yeah, those are those teeth again. Oh boy. What a deadly creature, eh? And she just likes to sleep like this with her paws over her face. She's great. Okay. Oh, where'd my stuff go? Here it is. Okay, let's move on. Let's try kind of a level B type question. Okay, so slightly more challenging. Okay, level B. Got x squared minus 1 over x squared plus 3x plus 2. Okay, great, let's do it. Okay, so I'm going to factor both of these. So I got to factor this. I've got to factor this. Okay, so that's my goal here. Because right off the hop, I don't know like how to simplify this, right? Because I don't know the factors, right? Like if I asked you to factor a fraction with a really big numerator and a really big denominator, you wouldn't really know if you could cancel any common factors until you knew what those factors were. So what we're going to do is we're going to factor these and then see if we can cancel any common factors that are in both the numerator and the denominator. So let's try that out. So I think that the first one, this is a difference of squares. So that's x plus 1 times x minus 1. That's good. So that's the numerator. And this denominator, I'm thinking that's going to be x plus 1 times x plus 1 times x plus 2. Okay? And that just comes with experience. Maybe you're able to do that in your head. Maybe it takes you a little bit longer to factor that. That's okay. As long as you're able to do it, it's fine. But if it is taking you a little bit of time, like if it takes you about a minute or longer to factor either of those, then I would maybe spend a little more time on, what was it, chapter 3? No, chapter 4 on quadratics and factoring quadratics, because we're going to be doing a lot of factoring, like a lot of factoring in this chapter. So it's going to be really helpful to be able to do this stuff quickly, because if you're spending lots and lots of time on factoring, then you're just not, it's not possible to spend as much time on the content that we're learning now, like the new content on what am I trying to say, on rational expressions. So we can see here that we have some common factors. So x plus 1 is a factor of the numerator, and it's a factor of the denominator, so they cancel out, and this gives us x minus 1 over x plus 2. So this is simplified. Now let's talk about the NPVs. Okay, so NPVs is the next bit. Okay, so NPVs, what gives us, oh, not NPS, NPVs. What gives us a denominator of 0? Well, here's what we're going to do. We're going to take a look at this original question, okay? And we're going to say, okay, in what case is this equal to 0? Well, it's kind of hard to say, isn't it? If only we could factor it. Well, look at this. We already have factored it. We already have. So lucky for me, I showed all my steps. I didn't skip any steps. So this is a great example of a case where showing all of your work is absolutely imperative. It's really important to show your work here. So I'm going to just go back over here and say, okay, well, when is the denominator, which is x plus 1 times x plus 2, when is this equal to 0? Well, that's when either of these is equal to 0. So when x plus 1 is equal to 0, or when x plus 2 is equal to 0. So we have two cases where we have a denominator of 0, where x equals -1 and x equals -2. So those are the cases that give us a denominator of 0. Okay, so denominator of 0. So our NPVs are x equals -1 and x equals -2. So those are our NPVs. Okay. So it looks like we've got just enough time to do an exit slip. But before we do the exit slip, I want to share something with you. And I've shown this to all my classes so far today, and I think that you'll find this useful. So give me a second just to pull up these tabs. Okay, I need Desmos. Okay, and I want to start graphing. And I'm going to get this ready. Okay, almost ready to go here. And okay, so I've got that up. I'm switching over to my computer, so I want to make sure that my computer screen is ready. Okay, so I want to punch something into there, and then punch something. Oh yeah, that's what I needed. My website. Okay, time to bring you over to okay, here we go. Okay, so here's the website. Here's Desmos. So I'm gonna write an expression down in Desmos, and I think a lot of you can probably have some experience with Desmos, and even if you don't have a lot of experience with Desmos, you can probably figure it out. It's fairly user friendly. So like for example, if I wanted to write this problem here, which I'm going to give you in a second. Why don't I try writing that last problem that we did, right? Like I think you can even do that without a keyboard, right? You can do like, what was it? X squared minus 1 divided by, oh, I guess I can't do that. Can I do that? Okay. So what I'll do, so you can see right away I've got a problem. So I'll put these in brackets, and then I'll divide by, and then again, x squared plus 3x plus 2, right? And that's the equation that we just had. By the way, this is what that equation looks like. Isn't that neat? That's what we would call a hyperbola. Yeah, pretty cool shape. Kind of like how we would call a quadratic, like when you graph a quadratic, you call that a parabola. We call this a hyperbola. So yeah, this is a cool shape. We'll be taking a look at this shape in a little bit. Anyways, this, and then now we can go back and we can delete those brackets. Like let's say for example, like I wanted you to do some kind of exit slip, or maybe it's on an assignment and I'm asking you to punch this in using Google Forms. So let's say for some reason I wanted you to punch this, like this was your solution, like maybe you needed to simplify it or something. or maybe why don't we write what we actually simplified it to? So that was so x minus 1 in brackets over x plus 2. And you could either keep the brackets there or you could remove the brackets because they're redundant. Oopsies. Okay, there we go. Okay, so let's say that, and look, see how it's the same shape? It's the same shape. I didn't change it. So when you simplify it, you should get the same shape. So anyway, let's say I asked you to punch this solution into Desmos. Well, I'm thinking that you could all figure out how to punch this into Desmos. Right? You can pretty much do it without a keyboard. Now, if I wanted you to submit this answer in the exit slip, that would be a little bit harder, wouldn't it? Well, I want to show you a little trick. You can copy this. If we copy this and paste it in here, it's going to look kind of funny. It gives you this weird symbol. Okay, I've got backslash frac, and then open curly bracket x minus 1, close curly bracket, open curly bracket, x plus 2, close curly bracket. Okay, that actually means something, and this is a computer markup language called LaTeX. Okay, LaTeX, and it's spelled the same thing as latex. And LaTeX is a way of writing mathematical equations and expressions using a computer. So it's a great little markup language. It works a lot like HTML. So if you've ever made a website or anything like that, or got into web design, it's a lot like HTML in that it's a markup language, not a programming language. So it's not like Python or C++ or anything like that. It's a markup language, like XML or HTML, any of those markup languages. So it's a markup language, and it's a markup language specifically designed for typing math. So you can see, like, this is Wikipedia's little example. This is what a LaTeX file looks like. So you have all these backslashes and everything, and it basically works like Microsoft Word does, except it's like the scientist's version of Microsoft Word. So if you look at these little commands, like they correspond with different symbols. So you can have like E sub 0 equals MC squared, and that appears over here, and this little equation appears over here. So I've been using LaTeX for quite a long time, about a decade now. So I'm fairly fluent at reading it. So what I'm trying to say is, if you copy this, and you can't right click it, it does have to, you do have to do like a Control C kind of thing. And if you just paste that into here, then that's perfectly fine. I can read that perfectly. So, and if I can't, if like for some reason it was like this weird equation that I didn't recognize, I can always compile it. So I've set a little blank LaTeX file, and if I just paste it into here, and then if you put $signs around it, that means that it's math, because math is money. And if I compile it, then if you give it just 1 second, yeah, there it is. Yeah, that's the equation. So I can compile it, and then I get this nice little PDF of whatever you type. By the way, this is how I make your assignments and stuff. If you've ever had to use Microsoft Word to make a equation, you'll learn right away it sucks. So mathematicians use LaTeX, and so if you want to submit your solution using LaTeX, you can go to Desmos and just figure out how to do it using Desmos, and then copy and paste it into the exit slip. So the exit slip for today, let me tell you what the exit slip is for today. So, oh yeah, and now you can't see my iPad anymore. Screen. Okay, there it is. Okay, so the exit slip is find all NPVs and simplify this guy right here. I've got 2x cubed minus 4x squared minus 30x all over 4x squared minus 20. Okay, so I mean, I'll give you a little hint. You got to factor these. So we got to factor both of these. So factor, right? And for the NPVs, like when is the denominator 0? Okay, so tell me two things. I don't know why I did 3. Tell me 2 things. The first thing I want you to do is tell me what the NPVs are. What values give me a 0 in the denominator? Which values of x can I not have? And the other thing I want you to do is I want you to simplify it. And my guess is that it's gonna be I don't want to say hard to simplify, but your solution, you'll probably have to use Desmos. So punch your solution into Desmos, copy it, and then paste that into the exit slip. So and if you have any trouble with it, let me know. And if you want to just type it out the way you would have, like maybe you would have oh, Mr. Bennett, it is x plus 1 divided by x plus 2. Like if you want to type all that out in English, that's fine too. But I think you might find it interesting to see what that code looks like, because LaTeX is a great markup language. I really enjoy using it. I don't see a purpose to learn how to use it like thoroughly in high school. I don't think there's a need for it. But if you do decide to study math in university, I think that's a great time to learn how to use LaTeX. So you can kind of think of it as the mathematician's version of Microsoft Word. It's a very powerful tool, so give that some thought. Anyway, that's it for today. So that's your exit slip. I should say, just to clarify, this is our exit slip. So this is for you to do. So far, the exit slips have been going. That looks like exit sup. What's up, exit? Yeah. So far the exit slips seems to be going smoothly. I haven't really had any complaints. It seems like people are able to submit them without any real issues. I mean, there's a couple people who are just I can't figure this one out, which is fine, and I can have those conversations later, just like a one-on-one conversation, saying like, okay, let's talk about this, but we don't really have to worry about that. So yeah, I think they're going okay. If you have any thoughts about the exit slips, definitely let me know. But yeah, seems like things are going okay. A few students have asked, like, oh, I watch the streams not live. I watch them like at my convenience, which is perfectly fine. That's the whole reason I'm using YouTube as my sort of my core platform, as opposed to like just Discord or maybe like another program like Zoom or something, is because I want it to be able to be accessed after the fact. My only concern is if you were to sort of not watch videos all week, and then all of a sudden the weekend comes and you have like 5 hours of math to watch, and that's not good. So, and I think I'm having deja vu. I think I've already said that to you guys, so I won't repeat myself. But yeah, just make sure you're not watching a whole bunch of videos all at once. And as long as you submit the exit slip, like even if it's after midnight, that's okay. Like I'm not gonna try to get super complicated or try to make your life miserable by like making you submit it before midnight. Just do it when you can, but do your absolute best not to let the videos pile up. Okay. So are there any questions before I sign out? No, it doesn't sound like it. Okay. No? Okay. So let me just make sure YouTube is good. Okay. If you want. Yeah. So the whole... Go ahead. Yeah, for the, I mean, because there's two things that I want you to do. First of all, I want you to find the NPVs, right? So the NPVs, like you could, just to give you an example. Oh yeah, you can't see my screen anymore. Let me bring you back up. Here's my screen. There it is. Okay, so let's say your submission is this. Like, let's say, for example, like the NPVs are 5 and 6. So you could say the NPVs are x equals 5 x equals 6. And then you could say that the solution, or the simplified, is this. And like, I don't know, you could like have it any way you want. So if we just use the last example as an example, you could say like x plus 1 in brackets over x, what was it, x plus 1 over x plus 2? I think that's what it was. Or x minus 1, not the, whatever it is. Yeah, x plus 2. X plus 2. And something like that would be totally fine. Like this is completely fine to write it like this. I have no issues with that at all. But if you wanted to, you could go into Desmos, and then like maybe you're not quite sure how to write something properly. Oops. Then you could just paste it and then have that. So whatever works best for you. I'm not trying to make this more complicated than it needs to be. I'm just showing you another tool that you can use if you're unsure how to write something in math. You can always just punch it into Desmos, because I think most people know how to make an equation in Desmos. And if you don't know how, there's lots of tutorials and stuff, and they can help you sort of along that process. So like for example, like square roots are kind of, this is kind of the one that gets a lot of people. So if you do the square root of x, right, that's pretty easy to write. But in LaTeX, in LaTeX, it looks like this. It's / square root of x. So yeah, I mean, like if you're ever concerned about how to write something, I'm saying that Desmos is a great tool to see what's going on. But if you have another way of doing it, that's fine too. Okay, any other questions? Oh yeah. Here's the exit slip here. You can take a screenshot of it or what have you. Yeah, so there's the exit slip, and it's also on YouTube too. So if you want to head over to YouTube, if you're in Discord right now, you can just watch it, hit pause, and then it'll just be up for you. Okay. So I'm gonna sign out then, and I'll talk to you guys tomorrow. And have a good rest of your day. Okay.